Tanakit. Rex is leading systems engineering and industry efforts at Panasas, a leader in the performance storage and parallel file system. This is prior to joining Panasas, Rex was a director of engineering at SGI for nearly 12 years. He was responsible for performance engineering and benchmarking. Rex received his BS in chemical engineering from UC San Diego and an MS from UCLA.
Thank you, Melody. When Panasas marketing person came to me and said, "Do you mind going to Australia to give this, give a talk?" I said, "Sure, why not? I love Australia." And she said, "What are you going to talk about?" I said, "Well, in engineering right now, we're developing a new product. We're going to use the SSD and hard drives, and we're going to put parallel file system on it." And that's all I told her. And then she, of course, put that in the title of the presentation. I just found that out on Sunday when I checked in. It's like, oh, okay, our marketing is really good. She's able to capture everything we're working on in a very quick sentence. So what I'm going to talk about is really the combination of parallel file system, give you a little bit of ideas what parallel file system is about, explain to you the technology that we put in using the SSD as well as the hard drives, and more importantly, what are the benefits that you can see when you put the best technology into a product. And today, I just found out it's October 31st, so happy Halloween. So I don't know whether you guys celebrate Halloween here. Normally in the US, I would be coming up, with the makeup on and things like that, but I didn't want to scare you guys, so I just put a suit on instead. I guess I have to stay here, I can't walk around. So the agenda here I'm going to talk about is what is parallel file system. I'm going to give you a little bit of ideas, give a little bit of history so you understand why we need parallel file system. I'll explain to you the benefit of that. And talk about SSDs. Most of you probably know and have used SSD, but I wanted to mention why SSD is important, is an important component in the overall strategy of your storage. If you haven't looked at it, I'll give you a quick reason why it's important and why should you care about it. And we integrate all of this into an appliance. So I wanted to share with you the benefits of having parallel appliance. So let me tell you, the next two slides are marketing slides, so bear with me. It's a marketing pay for me to be here, so obligatory 2 slides on Panasas. If you look at the original rate paper, the original rate paper is written by Garth Gibson, Katz, and Patterson. And Patterson is emeritus professor at Berkeley. Garth was doing his PhD with Patterson, and he wrote that paper. The original paper has Garth Gibson on it, and that's our founder. So Garth started the company, and we've been in business for over 10 years. Our headquarters in Sunnyvale, and what technology we provide to people is basically parallel file system and parallel storage. We sell it as an appliance. So that means you can plug it in, and it will be up and running in a matter of hours, not days, right? So that's what the technology we provide. So what do? We actually have if you want to see the real thing, we actually up in the upstairs on booth 39. Please come by if you want to see the real hardware. So what we do is we have something we call a shelf. A shelf could be either 40, 60, or 80 terabytes. We also have a lot of cache memory. We hold that cache for when you do reads or writes. It's all going to the cache. And we scale. And that's the most important thing about our product is we scale. So many of our customers start with hundreds of terabytes, and they can scale to terabytes, hundreds of terabytes. And many of our customers actually have petabytes of storage because it's so easy to add. So we start with 40 terabyte as the smallest, and we can go to multi-petabytes and anywhere in between. So that's it. We're done with marketing. Now let's go technical. But before that, let me give you a little bit of a history lesson on what's going on with the file system. So I'll give you a bit of evolution of parallel storage. Many of you look pretty young, so I don't know you guys remember Sun Microsystem in the early 80s. Start with the workstation, Sun Microsystem. It was great. I got to use the first Sun 1, Sun 2, and Sun 3. It was great. But the problem with Sun Workstation was that it doesn't talk to each other very well. Many users wanted to share files. We wanted to be able to talk to each other. So there was a problem. So what that does, Sun actually create a protocol. It's called NFS, Network File System, in the early 80s, in 1984. So that was, that's how NFS comes about. We were able to share files with each other and colleagues. And then there was a company called Auspex, was founded in 1987. And Auspex basically set up an NFS server and able to sell NFS server and storage to many companies. Was very successful. There were two engineers at Auspex by the name of Hitz and Lau. I'm sure Melody knows where I'm going with this. Hitz and Lau took the technology and started a small company at the time called NetApp. The rest is history. NetApp was very successful, or is still very successful in pushing NFS server into the industry. So that was great. We all use NetApp. But then something else happened in the early 90s, right? What happened was Linux emerged into the world. What that does is increase the number of cores, number of clients into the industry. The labs that I had, I used to have 8 nodes. I was pretty happy about it. But then when I have 128 nodes, now having problem because NFS is a bottleneck. And when I go to 512, now everything's slowed down. So clearly, this is a problem. And the national labs in the United States, Los Alamos, Livermore National Labs, has projected to go into hundreds of thousands of nodes at that time. So they know that this is not going to work. The scalability is a problem. So something else has to happen. Some company came up with something called cluster storage. What they do, they just keep adding more NFS server to the clients. And that's good, but it's created island of storage and also created bottlenecks. They did not remove it. So National Lab, so this is a bit of history in the late, mid to late 90s. National Labs in the US sent out RFP, request for proposal, to several researchers around the world to solve this problem. And Garth, is a professor at Carnegie Mellon, responded to that. And looking at the history, he realized that a new approach is needed. So he started Panasas to develop a parallel file system. And it's the precursor to PNFS, which is the NFS 4.1 standard. Okay, so let me drill down further to what this parallel file system is after this history. And if you take a look at the next couple of weeks with the supercomputing in the US, the average computers to crack top 500 is 8,000 processors, not cores, processors. The number one supercomputer in the world, Sequoia, has over 200,000 processors. So what I'm trying to tell you is that the trend continues. We have to go to a parallel file system in order for us to scale. You can't stay with a single-threaded model any longer. If you spend your money buying 1,000 nodes clusters, and then you stick with a single file system, what happens is you won't be able to scale, and the investment that you put into 1,000 processor won't return to you. So that's why parallel file system is important. So I'm going to skip this slide because I think it's more important that we go further into the technical area. The key, when you look at parallel file system, there are 3 concepts that you need to know. Okay, the first thing is we're going to separate metadata from data. And the reason for that is, in a standard NFS, the metadata is always on the top. Every time you're trying to access files, metadata get checked in. The file system is going to go, okay, what's the size of your files? What kind of RAID level? When is it created? These are all metadata in the top of your files. It's automatically attached to. and it gets checked every time you access files. So we wouldn't want to do that. We want to separate metadata from data so that the compute nodes, the client, can have direct access to the data in parallel. Okay, so that's the first concept. The second concept is data layout. Because now I'm taking metadata out of the data path, I need to have a map telling the compute nodes where the data are. So let me give you an example. If you have a gigabyte files, if I chop a gigabyte files up into, say, a megabyte chunk, right? A gigabyte, a megabyte chunk, so I have 1,000 of them. So I have 1,000 chunk. I'm going to spread this across multiple disk drives. And it's going to be random because I want to make sure that I get random distribution so there's no network bottleneck. So when I do that, I need to have a map. So I know that file foo is actually on disk 5, blocks 36, and disk 17, block 21. So it's a map. So you have this data layout. And then the last thing that you need to do, you have to have a back-end storage. The back-end storage is how the disk drive itself communicate with the controllers. You know, this is the key concept. Well, this is the key concepts to a parallel file system. Rather complex, but that's why we built a system as an appliance, so that you don't have to worry about all of this. We just build it in for you. So rather than having metadata server, we now replace them with what we call director blades, and the storage piece, we're replacing it with the object storage device or storage blades. So, you know, please come up to the booth 39 and take a look at the real hardware. So I mentioned metadata and data to you because both of these behave differently. Metadata tend to be small. Data tend to be large. Imagine you're taking pictures, right? So you're going to have, you know, at the metadata level, it tell you, oh, it's a Canon, is, you know, f-stop of 2.3, what have you, exposure and so on. But the image itself of your family is huge, right? Depending on, you know, whether you use 18 megapixel or what. So it's a very big. So this different type of data is better off to store differently in different places. The ideal design, if you're going to do this, then you probably want to use something that have very high IOPS, like SSD to store metadata and hard drive to store data. By the way, a little bit about SSDs, as I mentioned to you, it's not disk at all. Have you guys, any one of you open up SSD? Crack it open? Ah, man, you guys.
It's so expensive.
That's true. Actually, you can put it back after you open it up. It's actually a bunch of DIMMs, a bunch of memory chips inside it. So I crack one open and, you know, show that to you. So it's not a disk at all, but behave like one. So why do we care about SSDs, right? Why should you know? This is a bit of a hierarchy under storage. At the top is the CPU, right? CPU has register, has, you know, level 1, level 2, level 3 cache. And then you have memory and you have hard disk. That's a typical, you know, laptop, right? So if you take a look at latency, within the register, latency is basically under 20 nanoseconds, right? So that's very fast, you know, pretty good. When you go to memory, it's, you know, double that, you know, 2 or 3 times that to 60 nanosecond. That's why memory is expensive. That's why we all want to have, you know, 16 gigabytes, right, onto our laptop. And then when you go to hard disk, it's guess what? It's enormous. It's in milliseconds rather than nanoseconds. So that's where the problem happened, right? So SSD basically bridge this. It's actually give us somewhere in between. So that's the order of magnitude we're talking about. So SSD allow us, with a little bit more money, allow us to have larger capacity, be able to put more metadata or data in some cases. You know, if you have MacBook Air, it has SSD in there. So this is the reason why SSD makes sense, because the latency to the CPU is an order of magnitude better, actually 2 order of magnitude better than hard drive. So it's also use less power, right? So you have SSD doesn't have moving parts, so you have to use less power. So this is the blades, or the storage blades that I talked to you about. You can come upstairs. We actually have these blades upstairs. And what we have done, we actually, with the ActiveStore 14, we add SSD to the side. This SSD is, you know, 1.8-inch SSD. It can go up to a 500 gigabyte SSD. So when we put that in, and then we use our file system to control where the metadata data goes, and the metadata and small files as well go over to the SSD, so we can accelerate the performance of your data. So here's I'm running out of time, so I'm just going to give you a quick improvement. This is from my lab. When we run the test, you can see that SSD is really good at is on the reads, not on the writes. The writes are a little bit better. The reads, if you take a look at the bottom one on reads, random reads, it's basically 10x the performance of what a normal disk drive will be able to handle. So when you do, you have a lot of read, and that's the way to go. I know I have to get off, so I'll let you know that the strength of Panasas product is basically easy to scale. It's an appliance, so you can purchase this, plug it into your environment, attach your 10 gig switch, and voila, here we go. And thanks for your attention, and again, happy Halloween.
That leaves us a couple of minutes for questions. Any questions for Rex? Silence. All right.
Candies.
Thank you very much.
Thank you.
Rex, if we just